Uh, so hi everyone. Today we'll try to understand some common problems while training a GAN architecture. So GAN architecture, like if you have seen my previous video about GAN, so GAN is basically an adversarial system where we have two networks, generator and decoder, which fight with each other to try to train themselves, and they are in a basically a game system where each of them is trying to beat the other one, where the generator is trying to generate fake images and making the discriminator believe that the images are real, while on the other hand discriminator is trying to improve on itself so that it can be able to distinguish between real and fake images. So now the training of a GAN architecture is not as straightforward as it is for other CNNs and uh, LSTMs and RNNs. So basically, while training GAN architecture, it is a combination of training of two networks that is happening, generator and discriminator, and there are common issues that you can find out while training. So let's discuss the top three major issues. Oscillating loss. So as you remember from our previous video, both generator and discriminator are trying to work on the same loss function, that is a binary cross entropy. So the generator is trying to increase that cross entropy, while the discriminator is trying to decrease that cross entropy. So oscillating loss training, you might observe that the loss function while training for different epochs might be oscillating widely. So at time it can be negative, other time it can be way high positive, then other time it can be very negative. It is believed that you might see some oscillations of minor magnitude, but if the magnitudes are very high, then it can be problematic for training your GAN direction. Also, the magnitude of the loss should move in the magnitude of the loss should move in a particular direction. Though it can be oscillating, but it should move in a particular direction. It shouldn't be the case that at one time the loss is increasing, at the other time the loss is decreasing heavily. Other is mode collapse. So it can be the case that while training the GAN architecture, uh, the discriminator is not able to classify particular set of images. For example, assume that you are training a model on MNS dataset which has 10 classes. So out of all the 10 classes, the images generated by the generator for the 9 classes, say 1 to 8, 1, 2, 3, 4, 5, 6, 7, 8, the discriminator is able to classify between them, okay, which are fake, which are real. But for the class 9, the digit 9, it is not able to classify anything. So it is very confused. So in that case, what will happen, that the generator with the noise vector will try to replicate class 9 every time, because it has figured out that while training that discriminator is not able to work on a particular set of images, and hence it would be generating class 9 images only. Hence this will lead to a lack of diversity in the output of the generator. So when finally the generator would be trained, the generator would remember to generate out of any random noise, it would be generating similar images that are 9, so it won't be able to diversify on other classes as well, as the discriminator is performing poorly on 9. So the generator has got that key to increase the loss function. I need to generate this particular class only. This is called as mode collapse. Finally, uninformative loss functions. As I told you that both generator is trying to increase the loss function while the discriminator is trying to decrease the loss function. So at times you will see the loss function, the loss after training, that you see won't make any sense. So it can be the case that your loss is very high, but eventually both your generator and discriminator has been trained well, because in an ideal GAN, in the end, the discriminator should take random decision over the sample. So it should not be able to make any sense out of the images that is getting passed to it. And so in that case, the loss function would be very high. So generally, what we do is that we wish the loss function to be very low when when we are building out any image classifier, text classifier. But in this case, loss function might be very high, and still your model has trained well. So this is called as an uninformative loss function.